trinomials where our leading coefficient a is anything other than 1. In this case, it's 2, right? So this is what you do when your leading coefficient is anything other than 1. I don't know, I've just heard different names for this technique. I don't know if it has we named it this on this date or whatever. But, I'm just going to call it the throwback for whatever reason. So you take the leading coefficient, because we're used to it being 1, right? That's where our comfort zone is. So we want this to be a 1. So what we do is you take this 2 and you throw it back and you multiply it with the c. So now you get x squared plus 11x plus 12 times 2 is 24. Now if you look at this, this is just what we've been factoring all along. A leading coefficient of 1, right? So when this happens, we just jump straight to the parenthesis case, don't we? Put the x's here, so when we FOIL it, we get back that. Put our focus on c, which is 24. From here, there's one more step that's odd, but from here it's the same thing as factoring a trinomial with a being 1. So 24, that's a weird one. That's like 1 and 24, that's like 2 and 12, that's like 3 and 8, it's like 6 and 4. It's a lot of stuff, it's very popular. So if you come over here and you see which one would add and subtract in a way to give you 11. 1 and 24 wouldn't, 2 and 12 wouldn't, 3 and 8 would. So this guy right here is the one we're going to go with. So we put a 3 there and an 8 here. Everything's positive. So we don't have to worry, right? Everything's positive, so you don't have to worry about it. We said that. Now, see, this move I did right here, it's not just legal. It's illegal. It's a very illegal move. So you have to balance that out. See, when we multiply by the 2, now we're going to take these constants here and divide them by 2. So we balance it. So we come over here, divide this guy by 2, divide this guy by 2. Great. If it goes into that number evenly, perfectly, you just leave it how it is. So x plus 8 goes into 2 4 times. Great. If it doesn't go into it evenly, because 3 divided by 2 is 1.5, that's not a whole number. We don't usually factor stuff like that. You bring this 2 back, and you put it in front of the x. So you get 2x plus 3. And that's how you would factor something with a leading coefficient that's not 1. Okay, so factoring trinomials with the leading coefficient a being anything other than 1, which is a 4 in our case. Now, one thing I forgot to mention in the first example that I did is, if the leading coefficient is not 1, you don't just jump straight to doing this. You want to keep your factoring background fresh, if that makes sense. You want to keep GCF in the back of your mind, because that's the first thing I taught you when we factored, right? So, looking at this, applying the GCF to it, the greatest common factor, as far as the numbers are concerned, 4, 10, and 6, you can pull a 2 out of all those. So, if your leading coefficient is not 1, don't just jump straight into doing that throwback method that I showed you. See if you can pull the GCF out as far as the numbers are concerned. So we can pull a 2 out of here. So we get 2x squared minus 5x minus 3. If I pop the 2 back in, I'll get the equivalent expression. Now, our leading coefficient, so forget about that 2. It's just going to keep dragging down and being stuck to you. It's really not important. So, we're really putting our focus in on here, right? So, our leading coefficient is still not 1. It's anything other than 1. So now, we're going to start doing that throwback method. Okay? So this 2 is just going to keep hanging out here. I'm going to take this 2 and throw it back and multiply it with the 3. So pretty much what you're doing is you're taking a back and you're multiplying it with the c. So then you get x squared minus 5x. 2 times 3 is negative 6. It's just a regular, now it looks regular because our leading coefficient is 1. We said when that happens, we just jump to our natural stuff. you know, can't speak today for some reason. So you jump to the C now, right? Which is a 6 in our case. So 6 is not that bad, it's just 1 and 6 and 2 and 3. So it's then we focus in on the B, right? Which is negative 5x. The problem here is 1 and 6 would give me 5, and 3 and 2 would give me 5 in an addition or subtraction kind of way. So the next thing to do is come and look at the C and notice that it's negative. You know, if you've been foiling for a while, you know that the last two things that are going to get multiplied together are these numbers here. And the only way you can get a negative out is if you multiply a negative by a positive. So that whole plus minus thing is going to happen. We said when that happens, you jump to the middle term, and whichever sign, well, first of all, we didn't even decide if it was 1, 6, or 3 and 2, right? So let's just go with 3 and 2. Okay. Then I said you'd go with the middle term. The sign from the middle term goes to the bigger number. The bigger number is 3 here, so the negative would go there. So then the positive would go to the 2. Negative 3 times 2 is negative 6. And that does not work. If you did the inner outer check, you'd get a negative 3x here. You'd get a positive 2x there. Adding them together, you'd get a negative x. So I did not factor this correctly. So we know that this is not going to work for this example. We're going to jump with the 1 and 6 now and see if that works. So we put a 1 there, a 6 here. We got a negative here. That means a positive and a negative got multiplied. So we're going to resort to going with the sign of the middle term, and that's going to go to the bigger number. The bigger number is 6, so it will get that sign, and that guy will get the other sign. So I hope I'm not confusing you. I'm talking a lot, but if you've watched my other videos, you know, factoring, there's a lot of steps, but I'm sorry. Okay. And I forgot my x. Okay, so are we done? No, because when you're doing this throwback method, you have to be on your toes. You have to be very, you know. So what we said, when you multiply by this 2, that's illegal, right? Very illegal moves. You have to balance that out. Since we multiplied by 2, we have to divide these numbers here by 2 now. So I'm going to divide this guy by 2, divide this by 2. You said if it doesn't go in evenly, because 1 divided by 2 is 0.5, we don't factor stuff like that, right? So you bring the 2 back if it doesn't go in evenly. So you get 2x plus 1. But here it works out evenly, right? Because 6 goes into 2 3 times. So that would be it. This would be our given expression factored. There's the 2 on the outside that we decided to factor out with the GCF. And then the rest of the stuff was the throwback. Alright, factoring another trinomial. We notice that the leading coefficient is not 1. So we want to see if we could pull out a GCF, a greatest common factor. Looking at 3, 5, and 12, you can't pull a GCF out of those. So we're going to resort to the throwback method. Because if you can't do the GCF, you just jump straight to the throwback method. So we're going to take this 3, we want it to be a 1. So we're going to take the 3 and throw it back and multiply it with the 12. So then we get x squared minus 5x minus 36. 12 times 3 is 36. Now it's just a regular trinomial with the leading coefficient 1, right? So what we said, we just jump to our parentheses here, put the x's there. I have this whole whiteboard and I never just use it to my advantage. So put the x here and the x here. Now 36, right? Now you put your focus on the C, which is 36. So 36, that's like 1 and 36. That's like 2 and 18. That's like 3 and 12. That's like 4 and 9. It's like 6 and 6. Very popular, as you can see. So we come back over here and try to see which one of those two numbers would multiply to give me 36 and add or subtract in a way to give me 5, right? 1 and 36 would never do it, right? If you added them, you'd get 37. If you subtracted them, you'd get 35. 2 and 18. If you added them, you'd get 20. If you subtracted them, you'd get 16. It's not working. 3 and 12. If you added them, you'd get 15. If you subtracted them, you'd get 9. It's not working. 4 and 9. We might have something here. 4 plus 9 is 13. Not good. But 4 minus 9 minus 4 is 5. And that's what we want here, right? So that's the one that we're going to go with. 4 and 9, right? This C is negative, right? You know, when we talked about the foiling, we said the last two numbers you multiply together are the last things that you multiply when you foil. So to get a negative out, you have to multiply a positive by a negative. So I know I'm going to have the plus minus situation. So we said when that happens, you come to the middle term, which is a negative 5. Or it's just a negative, right? You come to the sign of this middle term here, and you give it to the bigger number. So it's a negative, so I'm going to give that to the 9, and keep the plus over here under 4. So are we done yet? No, because, you know, you gotta, you just gotta be careful, right? When you're doing this crazy method. It's really crazy. I mean, I've showed it to a lot of people, and a lot of people are impressed by it. And when I don't remember who showed me, but it's one of the best days of my life. Okay, so you know how we multiply by this 3 illegally? We have to justify that by dividing by 3. That's the only way that'll balance this out. So divide the numbers by 3. We said if it doesn't go in evenly, you bring the 3 back. So you get 3x plus 4, and then this goes in nicely. 9 goes into 3 times. So that's how that would look factored. And you could FOIL this out to see if it gives you an original expression if you'd like.